This video evolved to provide further support to surveyors in identifying crossovers on streams in developed areas where it can be challenging. Physics governs the form of a river. Gradients provide energy that is expelled/dispersed through erosion and deposition. The river moves largely as an undulating sine wave that leaves its pattern in the form of the channel. As the river flows, it uses the energy to scour the bed, and then as the energy dissipates, deposits it. So you have high and low energy zones in the river.
This is about 25 centimeters in depth, and that's about 40.
Scour areas are deeper and tend to have one steep bank and one gradual bank, like a check mark. Depending on the gradient degree of confinement, these may be up against a bank or in the middle of the stream. Deposition zones are either on point bars or riffle areas. Point bars tend to have materials that are suspended and then deposited, whereas riffle areas tend to have larger particles that are rolled by the stream as bed load. A crossover is the location on a stream where the flow of the river switches from being in an erosion mode to a deposition mode. At this location, the stream applies equal erosive force on both sides of the bankful channel, creating equal elevations on the banks, and the main concentration of flow is in the middle of the channel at bankful flows. Since it is a deposition zone for bed load, the materials are coarser and relatively uniform in size and depth across the channel. How well the channel reflects these features is dependent on how stable the channel is, and how much time has passed since the last bankful event. The specific characteristics of crossovers vary with the type of sine wave controlling the river. Most stream surveys are conducted in either step pool or riffle pool systems. With higher energies or in confined channels, the wave is tighter and undulates mostly vertical in what we call a step pool pattern. The flows scour on the outside of the wave and deposit on the step. These stream forms tend to not have point bars and show erosion on both sides of the stream. In developed landscapes, they are often present in areas that cut through abandoned ponds where slope is at least locally increased and the channel is temporarily confined by the old pond deposits. Step pool systems are identified by low sinuosity, little if any point bars, and if present on both sides of the river, higher gradients, and shorter distances between steps and pools. Riffle pool systems occur in a more moderately sloped, unconfined valleys where they can create larger meanders. Scouring tends to occur on one bank and the finer materials are deposited on the opposite bank on what is referred to as a point bar. The crossover occurs at the location where the river switches from scouring on one side of the channel to the other. At this location, the properties of a bank will noticeably switch from being in an area of deposition to one of erosion. It is identified by changes in angles, materials, and possibly vegetation. Determine whether stream section profile is vertical or horizontal. Identify transition areas between deposition and scour zones. Point bar to eroding bank, scour pool to short riffle. When you think you find the crossover, it will have a relatively uniform bed profile, and the bankful level will be at the same height on both sides. Walk the river a bit to make sure you know where bankful flows occur on the banks. Logs also tend to get trapped at crossovers, creating what are referred to as cross logs. In armored or channelized streams, the river must revert to a step pool because it is confined. It will start to form steps and pools immediately. Look for deposits where the step is located and erosion on the banks where scouring is occurring.